Hello children, I'm back with another chapter, metals and non-metals. Before I commence, just want to ask you whether you are able to complete your work or not. Children, please cooperate and try to complete all your work. Now, let's begin. This chapter is in two parts, children, part 1 and part 2. Today, in part 1, we are going to read about metals and non-metals and its physical properties, their differences, their origin and all. And in part 2, will be consisting of chemical properties of metals and non-metals. Children, I have also given some exercises which are related with the topic covered today. So children, please complete that work in notebook. Just want to give you a suggestion, children, don't leave pending work, otherwise it will become a big burden for you next week. So let's begin the chapter with a big smile. Now your chapter number 4 in class 8th is which one? Metals and non-metals. Now you have seen some metals here, and these are non-metals pictures. Now you will get to know some things about metals and non-metals. But before that, I just want to tell you something about the variety of substances found in nature. Now there are so many varieties of substances found in nature around you. There are so many things, and all those things are categorized into how many parts, children? 2 parts. One is natural substances and another one is what? Artificial or man-made substances. Now what do you mean by natural substances? These are those substances which are formed naturally. Very easy definition, and you are reading these things from so many years. For example, coal and petroleum. Now children, these natural substances, they are again divided into 3 types. Not 2 types, 3 types. Metals, non-metals and metalloids. Now metals, these metals are very hard, they are shiny in appearance. You know that you are always saying that my car color is metallic gray. So what is that metal? Now the spoons are made up of metal. So many cutlery things are made up of metals around us. Then non-metals, then metalloids. We are going to read all about these in this chapter. Now, artificial substances, definition is again very easy, that those substances which are not found in nature and they are made artificially by man. Example are what? Chair, table, tube light. All those things are what? Artificial substances. Now, when we are talking about all these things, the one thing which comes to us, that these things which are around us, what are they called? They are called actually, children, matter. Anything that occupies space and has mass, that is called what? Matter. Now for example, pen, ball, and then your spoons, then your wristwatch, then your books, notebooks, and all those things, they are having some mass and they are occupying some space also. So what is that called? Matter. Now this John Dalton, one of the scientists, a great scientist, he gave Dalton's theory in which he clearly stated that matter is made up of small particles called atoms. See children, all these things, when you will break them into small ones, very small one, again and again, smaller, they can be broken into very smaller pieces. And one such small piece which you will not be able to see with your naked eye, that the smallest piece of that matter is called what? An atom. And who discovered that? John Dalton. Then one more great scientist, Niels Bohr. That Niels Bohr theory, that he said that this atom, it is spherical in nature. It is round in structure, spherical in nature, and it has also a nucleus placed in the center of the atom. You know that our human body, animal body, or plant body, it is also made up of one kind of structure is there, and that is also made up of, you know, that cell. The smallest part of a living body is what? A cell. So the Neil Bohr theory said that an atom is also spherical in nature, and it has a nucleus placed at the center of the atom. There is a nucleus also which is at the center of the atom, and these atoms, no, they are electrically neutral. He said that it is a very important point, children, that he is saying that atoms are electrically neutral. They do not have any charge. But he again stated that atom has three subatomic particles also, like the smallest particle of an any small thing, the smallest particle of any small thing is called what? Atom. And Neil Bohr has discovered one more thing, that this atom has again smaller particles, subatomic particles, which are again smaller than atom, and they are again not one, it is again three. And what are those? Electrons, protons, and neutrons. Now he said that electrons are now always carrying negatively charged particle. Electrons are always carrying what? Negatively charged particle. I know I'm saying so many things to you and it will get jumble up in your mind and all those things, but children, just I want to give you a small introduction, very very small introduction, which you may be going to read in 11th standard, the bigger one. But I'm going to give you a small basic things, that a particle or a thing is made up of atom, and atom has again three smaller subatomic particles, which are called electrons, protons, and neutrons. And you just learn that electrons are negatively charged particle, protons, it starts from P, learn it like this, protons which starts from P, that are positively charged particles, and neutrons, they do not have any charge, they are neutral. Neutron, N, it starts from N, and so they are neutral, they do not have any charge on them. Now I'll just, for your information, I want to give you that picture of an atom. Now the atom, this is a picture of atom, children. An atom is consists of a nucleus. In the middle, in the center of the atom, what is there? A nucleus. And nucleus is consist of which two particles? Neutrons and protons. Neutrons and protons, children, they are not able to move from their places, they are immobile, so they always present inside the nucleus, while electrons, which can be movable, and you know that electrons are negatively charged particle, they are movable also. That is why they always move in orbit around that nucleus, and these orbits are also called shell, children, they are also called shell. So I'm going to read it about this. In an atom, there is only one nucleus which is placed in the center. Okay. It consists of protons and neutrons. Protons are positively charged particle. Neutrons, they do not have any charge, and they are inside the nucleus. Because why they are inside the nucleus? Because they are immobile. They are not able to move. So they are inside the nucleus, they are present inside the nucleus, while electrons move in orbits. The electrons are moving in orbits, which are also called shells, as they are mobile, so they move around nucleus. Okay, children, got it? That this is the picture of an atom. An atom is consisting of three particles: electrons, protons, and neutrons. Out of that, neutrons and protons are present in the center of the nucleus because they are not able to move, while electrons, they are present in the orbit around the nucleus because they are movable, and electrons, we know they are negatively charged particles, they can move, so they are present in shell. Now children, there's something important which I just want to discuss. I'll not, this is not in your chapter at all, but just I want to give you an introduction that the shell, these electrons, no children, actually no children, there are so many elements present in around us, so many elements, and out of that 118 elements are already discovered. They are there in the periodic table. If you have seen some chemistry notebook, and the first or second page only, there is a periodic table given. In that there are 118 elements are already discovered. The first element which was discovered is gold, children. The first element which was discovered is gold in 6000 BC, and later on slowly many elements are discovered. Until now the scientists are trying to discover new and new elements. Now each element are placed in an you can say in an organized way according to their properties. They are placed in a periodic table in an organized way. Now so all elements, like the first element which is there in the periodic table is hydrogen, and its atomic number is only 1. The second element in the periodic table is helium, and its atomic number is 2. Then the lithium's number will come, and its atomic number is 3. So there is particularly, they are organized in a very proper way according to their properties and all in a periodic table. You are going to read all these things. I am just giving you an introduction so that you will be able to cope up easily in 9th standard. When you will come in 9th standard, you know that these words we have heard in 8th standard also. So now children, these electrons, it is not that only one shell is there around the nucleus. There are number of shells around the nucleus. It depends upon their atomic number, the element got. Like the first atomic number element is hydrogen, the 2 atomic number element is helium, 3 is lithium, then 4 is boron, then then there are so many: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen. Like that, they are there in they are placed in the periodic table. Now, so according to that, there are number of shells around the nucleus. Now, the shell which is the last shell, the outermost shell of an atom, is called what? Valence shell. Like if the atomic number of any element is 4, then see children, the electrons are also arranged in shell with some rules and regulations. Some rules and regulation are there. Like in the first shell, only 2 electrons can come. In the next shell, only 8 electrons can come. So there is some particular numbers are there. So just right now you just know, you must know that the outermost shell of an atom is known as valence shell, and the electrons which are present in that outermost shell are called what? Valence electrons. There are 2 things. The outermost shell of an atom is called what? Valence shell, and the electrons which are naturally, if the shell is there, the electrons must be present there. So electrons which are present in the outermost shell are called valence electrons. Now one more word is there, like valency. Now this valency is used when one atom combine with another atom. See, some atoms they live alone, but some atoms they try to combine with some another one to live. So some of us, they want to live alone, isolated and all. But some of us know they do not want to live alone. They just want the company of others. So same way with the atoms also. Some of the atoms they want to live alone. But some of the atoms when they combine, they live in a groups also. So group only. So they want to combine with another atoms. At that time, children, this valency is used. When one atom combines with another atom, this valency is used, and valency totally depends upon valence electrons. So, and valency is depending upon what? Valence electrons. Like in the outermost shell, if there are 2 electrons present, the valency of that atom is what? 2. Now, if the outermost shell there is 1 electron, the valency is 1. In an outermost shell, if there are 3 electrons, the valency is 3. But as soon as the outermost electrons become 4, 5, 6, 7 or 8, then the valency depends upon what? Then there is a formula. You have to subtract from 8 that number, the number of valence electrons, and then you have to get the valency. Like if the last shell has 4 electrons, then you have to subtract from 4 from 8. So now the valency of that particular atom is what? -4. So till 3, the valencies will remain as +1, +2 and +3. But as soon as the valency will become 4 or -4, valence electrons will become 4, it has to be subtracted from 8, the valency will become -4. If the valence electrons are 5, it has to be subtracted from 8, the valency will become -3. If the valence electrons are 6, in the last shell 6, then it has to be subtracted from 8 and the valency will become -2. If the valence electrons are 7 in last valence shell, then it has to be subtracted from 8 and the valency will become -1. And if the valence electrons are 8 in the last shell, then 8 minus 8 is 0. Now this 0, children, these are again called some type of elements in the periodic table, and they are called noble gases. I'll just give you that the valency of the atoms whose valency becomes 0, those are called what? Noble gases. The elements whose valency becomes 0, those are called noble gases. Okay, so I'll explain you one more time that this is the structure of atom. Atom consists of electrons, neutrons and protons. Protons are positively charged particles. Neutrons are neutral, while electrons are negatively charged particles. Now the shell, which is the outermost shell of an atom, that is called valence shell. The electrons which are present in this outermost shell are called valence electrons. And valency is used when one atom combines with another atom. So valency is totally depends upon valence electrons. Now from here we'll get the difference between metals and non-metals. Now metals and non-metal, what is the main difference? That these substances have 1, 2 or 3 valence electrons in their outermost shell. What are valence electrons? Valence electrons are those electrons which are present in the outermost shell, that is called valence shell. So if the substance is having 1, 2 or 3 valence electrons, they are called metals. And if the substances have 4, 5, 6 or 7 valence electrons in their valence shell, they are called non-metals. Understood, children? I feel you must have understood that. Now the second is what? They always have tendency to lose electrons. See, these electrons, when they are having, like when they are in 1, 2 or 3 number in the valence shell, they always have tendency to lose electrons. They always try to lose themselves and they want to stabilize themselves to make them stabilize. They want to lose electrons. So metals always have tendency to lose electrons. Whatever they are there in the valence shell, they want to lose them. And these non-metals, they always have tendency to gain electrons. Their valency is what? Their valence shell, there are either 4, 5, 6, 7 electrons are there. So they have a tendency to gain electrons. They are electropositive in nature. Actually, children, this electropositive means they have their valency will become positive. How they become positive? See, if they want to lose electrons, if they lose these 2 electrons from their valence shell, what will happen? Now there will be no negative, there is no negative charge left in this atom. And now which charge is more in this atom? Positive charges are more in this atom. So children, we can say that metals are always electropositive in nature because they have a tendency to lose electrons, and electrons are always negatively charged. And when an atom loses those negatively charged particles, what happened to that atom? The atom is consist now mostly of positive electrons, so positive protons. So now that atom is actually electropositive in nature, and just opposite of that, these have a tendency to gain electrons. So it means they are gaining negative electrons. So if they are gaining negative electrons, they are taking electrons, then what happens? They are more, electrons will be more in number, and if the electrons are more in number, more negatively charged particles are there in the atom. So we can say that non-metals are electronegative in nature. Have you understood, children? Now the fourth one is what that I already explained you, that I already said to you right now, that their valencies can be +1. I said that electropositive, and if the valence shell electron is 1 only, then they are losing only 1 electron. So that means their valency is +1, +2 or +3. And their valencies can be -4, -3, -2 and -1. And how they'll get it? They have to subtract it from 8, because a shell, maximum number of electrons a shell can have is 8. So we have to subtract it from 8. If they are having 4 in valence shell, we have to subtract it from 8, and the valency will become -4. If they are in the valence shell, they have 5 electrons, then we have to subtract it from 8 again, and we'll get -3. If they have 6, then subtract it from again 8, we'll get -2, and same like this. 7, if we'll subtract 7 from 8, we'll get -1. So they are electronegative in nature. I feel that you have understood this. If you have not understood, children, please go through with the explanation one more time, and it will be very easy to understand. Just for your introduction, I gave you all these things. Now children, the very important part in this chapter is what? How to write a chemical formula. Now formula means we'll always say that carbon dioxide, the formula of carbon dioxide is CO2. How we got that? And H2O is the formula of water. Then sometimes you're in 7th standard, you must have gone through with acids and bases chapter. There also we told you that sulfuric acid is H2SO4, calcium hydroxide is CaOH twice, then sodium hydroxide is NaOH twice. But how we got all these things? So to learn that, I'll just I gave you some examples also, that how to write a chemical formula. First of all, you must know the symbols of that element which you are using. Like if I'm saying sodium hydroxide, so sodium symbol is what? Na, and hydroxide symbol is what? OH. So you must know the symbols of the elements or radicals. Radicals are what? Like hydroxide is a radical which constitute the compound. Radicals are what? They are made up of compound, and they have some charges also. Now you must know the valency of the element. You must know the valency of the element, and for your benefit, I have given you a valency chart also, children. Please try to learn those valency, some common elements valency. It's not that I'm saying all 118 elements to learn those valencies and all. No, some common elements valencies I gave you at the bottom. You just go through with those valencies and try to form different formulas with your parents. Sit with your parents and do this activity, children. Now the method applied for writing the chemical formula is called crisscross method. Now how to do? Now one example, that I have taken a K. K is what, children? Potassium, and Cl is what? Chlorine. Okay, fine. Now the valency of potassium, now check it in the lower one here. The valency of potassium is what, children? +1. When it is written plus only, that means the valency is 1. And chlorine's chlorine, that is chloride valency is what, children? -1. Now children, the first one is a positive charge, so that means it is a metal. And the second one, I said that they are electronegative in nature. So this chlorine is actually what? A non-metal. Always metal comes first and non-metals comes in the second position. So whenever we are writing a formula, metal should always, the positive charge positive charges, those, that means metal should be written always in the first place, and secondly we write a non-metal. Now the valency of K, potassium, that means K is the symbol of potassium. So what is the valency of potassium? 1. And what is the valency of chlorine? 1. Don't go on charges, just see that the valency is 1 and chlorine's valency is also 1. So what we'll do, we'll write 1 here and chlorine's also 1 here. Now next, in the next step, what you have to do, you have to crisscross it. This one, the chlorine's one, will go in the as a subscript of potassium, and this potassium valency will go as a chlorine's subscript. So this one will come here and this one will come here. Now the formula become what? K1 and Cl1. Now 1 and 1, they are actually in the maths also, you say, you will always, you also know that anything divided by 1, anything multiplied by 1, they remains 1. So 1 and 1 will cut and the formula become what? KCl. Ignore that 1, children, and the formula will become what? KCl, and it is a formula of what? Potassium chloride. Potassium chloride. Now potassium hydroxide. Now again see this K, the valency of K is 1, and hydroxide, again check it in the bottom, I gave you here that valency chart. Now this is hydroxide, see here it is hydroxide. Hydroxide's valency is what? Again minus 1. So, or 1 minus, so 1, I said no, that don't take charges, you know that this is a radical. Now this is a radical, it is a compound and it is a radical. So the 1 will go down here and this one will again go in as a subscript of potassium. Now again this K1 and OH1. Now this becomes what? KOH. So that is what? Potassium hydroxide. K is a symbol of potassium. Now next is what? Calcium chloride. Calcium. Now this is calcium. Calcium's valency is what, children? Check it in your this valency chart. Calcium valency is what? 2. Calcium's valency is what? 2 plus. And chloride, we know already that it is 1. Now put that 2 plus on the top. Cl, take the formula of symbol of chloride, that is Cl, and 1 minus. Now this 2 will go down. I said no, that leave the charges there. Leave the charges there. This 1 will come as a subscript of calcium. This valency of calcium's valency, which is 2, will come as a subscript of chloride. And then it becomes what? Ca1, Cl2. Now 1 you can ignore. Now the formula will become what? CaCl2. So this is what? Calcium chloride. Same way calcium hydroxide, children. Calcium's valency is 2. 2 will go as a subscript of hydroxide. Hydroxide is a radical, children. It is a radical, it is a compound. So the 2 will go on both O and H. So O and H will be in brackets, children. O and H will be in bracket. This 2 is for O also. This 2 is for H also. Now and 1 will go as a subscript of calcium. Now this becomes what? Ca1, OH twice. 1 will be ignored, and radical is always in a bracket because it is a compound. So the formula becomes what? Calcium hydroxide. This is a base, calcium hydroxide. Now the third one, I have taken an aluminium chloride. Now the valency of aluminium, check it in your chart, that aluminium's valency is 3 plus. So here again 3 plus, you know now 3 will go as a subscript of chloride and 1 will go as a subscript of aluminium. Here again 3 will go as a subscript of hydroxide, 1 will go as a subscript of aluminium. The formula will become what? AlCl3, and this is aluminium chloride. And here again the formula will become aluminium hydroxide, and hydroxide should always be in bracket because it is a compound, it is a radical, so it should be always in bracket. So this is the way we have to write formula. So before writing formula, what do you know? That you must know the symbol of that element which you have to write, then you must know the valencies, then you just crisscross it and get the formula. Children, this is the valency chart I was talking about in the previously that you have to learn this one, like hydrogen, sodium, silver, potassium, lithium, ammonium, barium. These are the common elements, children, which you will get it till 9th standard only. I'm not saying till 11, 12. 11, 12, so you have to learn so many things. But for 9th standard till 9th, 10th standard, beta, if you are going, bacho, if you are going to learn all these things, no, if you all learn all these things, it will be enough for you. Okay, now here we are on physical properties of metals. Now children, metals, you know, they are electropositive in nature. They are, again I'm saying, they have a valency of +1, +2 and +3. Be careful, they have a valency of +1, +2 and +3. Now there are some like while looking, what do you mean by physical? While looking, by holding it, we can say that this is a metal or this is a non-metal. So when these properties which we come to know by just touching, seeing and looking their color, and we'll say that, oh, this is a metal. So there are some properties of metals also. One such property is what? It is malleable. It is malleable. Now first one, malleable, is that property of metal which allows them to beaten into thin sheets. Now we know that we have an aluminium foil which can be beaten into thin sheets. You know that you are using aluminium foil in your tiffin. I'll show you that this is aluminium foil. This one is aluminium foil, and this is aluminium is what? A shining metal, and it is made up of a metal only, and it can be beaten into thin sheets. Like our jewelries also, I'll show you some jewelries also which I have. These are beaten into thin sheets only, then only we can make some jewelries. So the first property of metal is what? That we can beaten them into thin sheets, and due to presence of this property, the shape of iron nail, aluminium wire can be changed on beating. Now, for example, the silver foil used for decorating sweets and the aluminium foil used for wrapping food, these are the examples of malleability of metals. Malleable metals are aluminium and copper. Highly malleable metals are what? Gold and silver. You know that the gold and silver are basically used for making jewelries, and if they are not malleable, if they are not beaten into sheets, it is not possible for us to make jewelry from that. So highly malleable metals are which one? Gold and silver. And the metals which are malleable are what? Again, aluminium and copper. Now second one property is what? That conductivity. You heard this word again and again. It is that property of metal which allows the current and heat to pass through them easily. You know that the metals are allowing current and heat to pass through them. Metals like iron rod, nail, copper wire, etc. are good conductors of electricity. I'll also show you some one of the metal. I have a copper metal in the wire. Can you see that, children? Copper metal in an iron, and it is coated with plastic also. And why it is coated with plastic? Because plastic is an insulator. It does not allow, and plastic is a non-metal also because it is made up of a carbon. It is a carbon compound only, so it is a non-metal also. And the copper which is there inside it, this is a what? Metal. And metals conduct current, and metals also conduct heat. Like we are using this spoon or the utensils in the kitchen, all those things are what? They are made up of metal, and they allow heat to pass through them easily. That is why we can cook food in the metallic container, metallic utensils only. We are cooking food in the, are we cooking food in wooden vessels? No, we are not cooking food in the wooden pans, and all the pans are always made up of metals. So we can say that metals are good conductors of heat and electricity. Now the next one is what? Ductility. It is that property of metal which allows them to be drawn into wires. It is again a very good property, like a malleability property only. The malleability property allows a metal to drawn into thin sheets, while ductility property allows what? It allows the metal to drawn into wires. And like a wire of 2 kilometers long can be drawn from 1 gram of gold. See children, a wire of 2 kilometers long can be drawn from 1 gram of gold, because gold is a highly ductile. Gold is a highly malleable also. Gold is highly ductile also. Now, for example, metals like aluminium and copper are used to make wires which are used in electric connections, as they are ductile metals. Zinc, arsenic and antimony are non-ductile metal. These are exceptions, children. Like if the question can arise that write any two metals which are non-ductile, so then you have to learn it that zinc, arsenic and antimony are non-ductile metals. And this is the picture of ductility, like the metals when they are drawn into wires, that it is a copper wire which is shown. Now ductility, the most ductile metals are what? Gold, aluminium and copper. And non-ductile metals are zinc, arsenic and antimony. And their symbols are also given, like copper, the symbol of copper is Cu, aluminium A and Al, then gold Au, zinc Zn, arsenic As, then antimony Sb. So here that one thing is mistake, children. It should be capital A and S, and it should be capital S and small b. Small b. This is the mistake, children, here. Now copper is, see that always you have noticed that the first letter is capital and the second letter is small. There is some rule for this chemical symbols to write also, children, that you will be getting to know in next class only, in 9th standard. I just don't want to say you all those things right now, but just notice that first letter is capital, second letter is always small. And it is not in cursive, it is in a that form only, alphabetical form only. Now the fourth property of metal is what? Sonority, sonorous property. Now sonorous means what? When it produces ringing sound on hitting. Like I'll show you. I'll take 2 spoons and I'll make, see that ringing sound is producing. But if I take 2 plastic, will it ring like that, children? No, it will not ring like that, like how that ringing sound is produced of metals. Now even the bell, the temple bell, it is also it also gives the ringing sound. That is why the temple bell is made up of metal. Now that means, and the question is also here, now ringing property of metal depends upon what, children? Temperature and density. It depends upon temperature and density. Now why that bells are made up of metals? Metals have sonorous property. Ringing sound produced by metals is known as sonority. So bells are made up of metals. Now the next property of what of metal, that is lustrous. Metals in their pure form have luster, that means shine. It has shine. In their natural form, in their pure form, they have luster. But sometimes this metal, when they comes in contact with oxygen and moisture, they oxidize and they get rusted. They get corroded. And so we can say that metals in their pure form, they have luster, which makes them shine, and their structure are capable of reflecting incident light. Reflection also you have read in class 7, reflection, and they reflect the incident light. Okay, so for example, gold, silver, copper and platinum, all you must have seen this gold and silver jewelries, copper vessels, then copper wire, all these have shine. They all these have their natural luster. Iron also have their natural shine. So those are metals have one more property, that is lustrous. Now one more property of metals is what? That metals are hard. What are metals? Metals are hard. Due to the ductility and malleability properties, metals are very strong, and some of the metals which have the properties of non-ductile and non-malleable are not all strong. See, those metals which are non-ductile and non-malleable, they are not strong. But some of the metals which are having a ductility and malleability properties, which can be drawn into sheets, which can be drawn into wires, they have which property? They have hardness property. While like metals like sodium and potassium are soft, they are children so soft that they can be cut with a knife also. And the hardness varies from metal to metal, children. It's not that all metals are hard in the same way. No, the hardest metal is iron, and then copper, then aluminum, then magnesium, like that. So the hardness varies from metal to metal. Now most of the metals are solid. Most of the metals are solid at room temperature, but you can say that mercury which is present in thermometer, they have what? They are what? They are liquid. They are liquid at room temperature. You must have seen thermometer, and you must know that thermometers are having mercury inside them, and mercury is a metal. It does not stick on the thermometer glass thermometer's wall. That is why we are using mercury, because it again expands on heating. So metals expands on heating, you know very well. So that's why we are using mercury in the thermometer. Now one more metal, gallium, which is also found in liquid state at room temperature. Very important question, children. These are the things which I have given you in red color font. That those are very important. Mercury and gallium are metals which are found in liquid state at room temperature. Now metals have high melting and boiling point also. Most of the metals have high melting and boiling point. The metals which are solid in nature always have high melting and boiling point, because they are closely packed and have a high attraction between them. And there are some few exceptions. Again, what? Those which are soft, no, they do not have high melting and boiling point, like sodium, potassium, mercury and gallium, which are liquid in state. They do not have high melting and boiling point. So we can say that the most of the metals which are hard, which are solid in nature, have high melting and boiling point, while sodium, potassium, which are soft, mercury and gallium, which are liquid at room temperatures, have low melting and boiling points. Next is what? High tensile strength. The metals which can bear the strain are termed as high tensile strength metal. Here are few exceptions. Again, those metals which are not having high melting and boiling point, like zinc, arsenic, antimony have low tensile strength. They cannot bear the strain, so they are called low tensile strength. And so most of the metals have high tensile strength. So understood, children? There are 9 points I have written. Even you can say that the metals have high density because they are heavier. So metals are having a higher density also. One more point you can add it into that. Now introduction to non-metals. See, this is the picture of coal, children. Coal, you have seen coal. Coal is made up of carbon, and carbon is a non-metal. Now what are non-metals? These metals have a tendency to gain electrons and are electronegative in nature, are termed as non-metals. Materials like coal, sulfur are soft and dull in appearance. They are always dull in appearance, children. They are not shining. They are not shiny, just opposite of metals. They break down into powdery mass. They are not very hard. They break down into powdery mass on tapping with hammer. While you know that metals are malleable and ductile, they can change and they can be drawn into sheets and wires. But these are non-malleable and non-ductile. They are non-sonorous. They do not produce ringing sound when they are heated. So they are non-sonorous, and they are poor conductors of heat and electricity, just opposite of metals, children. For examples, few examples of non-metals are sulfur, carbon, oxygen, iodine, hydrogen, etc. Now the question arises that why these are, then what is the use to study about non-metals then, children, when they are not hard, when they are dull in appearance, when they are non-sonorous, when they are poor conductors? So why to study about non-metals? No, children, when you will think about metals and non-metals, the non-metals are more around you. how can I say like that? Because we cannot survive without them, like oxygen, carbon dioxide. These all are non-matters, children. Without these, can we survive? No. These are very important gases for us, for animals and plants, and even children. In air also, non-metals are present. Air constitutes of non-matter, like nitrogen, which is 78% in air, and nitrogen is what, children? A non-matter. They are, children, these non-metals are excellent fuel, like coal is an excellent fuel, children. To clean water, we need what? Chlorine, and chlorine is a non-metal. To clean water, we need what? Chlorine, and chlorine is a non-metal. It is also used in antiseptics like iodine and all. And hydrogen, you know that hydrogen is a very important gas to make some you can say it for using them as a hydrogen bombs and all. We are using them. So there are so many things in non-metals which are very important, children. And most of the around us, around us, we'll find most non-metals around us. Those are what? Oxygen, carbon dioxide, nitrogen. They are constitute of non-metals, children. So physical properties of non. So that is why we can say that we should study about non-metals. But these, out of these non-metals, no, children, this carbon was introduced in very prehistoric period. This only carbon was introduced by scientists, but otherwise all metals were introduced. And later on, when they get that okay, non-metals are very important for us, then these non-metals are discovered in the later stage, children. In prehistoric period, only carbon was discovered. So and out of this periodic table, no, in 118 elements, children, total 92 elements you can say are metals and are made up of metals and non-metals. And out of 92, no, children, 22 are non-metals and 70 are metals. So number of metals, you can say, in an elements, the number of metals are more, but around us, if you will see, the quantity of non-metal is more. Though it is discovered in later stage also, and they are 22 in number only, in elements only, like this oxygen, carbon dioxide, hydrogen, nitrogen. All these are non-metal, and they are in 22 in number. But around us, if we'll see, non-metals are more around us, and non-metals are very important for us than metals. It's not that metals are not important, but yes, non-metals, for surviving, it is more important for us. Now, physical properties of non-metals, very fast we'll do it. Non-malleable, we know that metals are generally brittle. They cannot be beaten into thin sheets and drawn into wires. So we can say that non-metals are non-malleable and non-ductile. When stress is applied on non-metal, they shatter into pieces. Sulfur and phosphorus, these non-metals are in the form of powder and cannot be beaten. Now, non-ductile, again we have discussed right now, they cannot be melted and drawn into thin wires. They are brittle in nature. Then they are poor conductors of heat and electricity, because they do not have any free electron. Well, graphite is an exception. Graphite, you know, it is present in your pencil lead also. Graphite is an allotrope of carbon, and it is a good conductor of electricity due to its special crystalline arrangement. It is used in making electrodes also. Then it is non-sonorous. Sonorous means it does not produce any ringing sound when hit with an object, are known as non-sonorous. For example, phosphorus, which is present in powdery form only. Okay. Then non-lustrous, these are again dull. These are non-metals are in the powder or gaseous form, hence they cannot be polished and they do not have any luster. But non-metals are generally non-lustrous and dull. Carbon, but exceptions are always there. Carbon, like graphite, one of the carbon compound, which is graphite, and iodine, which we are using as an antiseptic and all. They are exceptions. They have luster. They are lustrous as their surface possesses a shine. Now, softness, non-metals are generally soft, but Due to non-ductile and non-malleability properties, non-metals are not strong at all. But one exception is again here, carbon compound, the diamond. Diamond, which is a carbon compound, is an exception. And diamond is very hard. In fact, diamond is the hardest natural substance known. So you can say that diamond, it's again an irony, children, that non-metals are not very hard, but one of the hardest non-metal, diamond, which is the hardest natural substance actually. Now solid liquid, they are not always solid, they can be liquid also, they or gas also. So they can be solid, they can be liquid, they can be gas at room temperature. Non-metals may exist in all three states at room temperature. Carbon, sulfur, phosphorus are solid at room temperature, while nitrogen and oxygen are gaseous non-metals, and bromine is a non-metal which is liquid at room temperature. Now I gave you picture also. This is phosphorus, which is in the solid form, bromine, which is in the liquid form, nitrogen, which is in the gaseous form. Now they have low melting and boiling point because they are soft, they can be loosely packed also. So they have what? They have low melting and boiling point. Less heat is required to melt or boil them. Hence non-metal possess low melting and boiling point, except graphite. Here again a exception is there, children. This graphite is an exception everywhere. Carbon graphite is a non-metal but possess high melting point. Now they have low tensile strength. Non-metals cannot bear the strain. They have low tensile strength. They are not strong and get easily broken. We can add one more, that they have low density also, because they are not in the solid form. So they possess less weight, less mass. So you can say that they have less density also. So here that chapter ends, children. That's all for you. Metals and non-metal properties we have done today, and whatever I explained you about atom and their chemical formulas and the way the atomic the subatomic particles move around. So you know, now you got everything, I feel. And if you are not able to get it got that, then please go through one more time, children. Please one more time go through with the video and try to understand all these things. In the next part, I'm going to give you chemical properties of metals and non-metals. There those chemical formulae will come so many times, children. So that's why I'm saying that do practice of that those chemical formulas also, which I gave you a valency chart. You just know, some of you please do practice, so that you will able to understand this chapter very well. That's all, children. I'm giving the exercises of the chapter also, which I have covered the chapter also, which the topics which I covered. No, I'll give the exercises from them only. So please try to please complete those exercises in your notebook, children. Okay, bye bye. Thank you everyone. God bless you all.